Lesson 212, Part A, Interpreting Various Forms of Quadratic Functions in Vertex Form. All right, example 1. So looking at vertex form, it's a bit different than standard form. So if we look at this here, so remember standard form was ax squared plus bx plus c, but this time we have, h and k in here, incorporated into here. So vertex form is going to be that there. It's a times x minus h squared plus k. Okay, so anytime you see that, you want to start using these 5 steps. Okay, so step 1, and you see the difference between the two. I believe vertex form is a bit easier than standard form. So step 1 remains the same. This is parabola open up or down. If a is positive, it opens upward. If a is negative, it opens downward. If we look at a, it's the number in front of the parenthesis. The number in front of the parenthesis, it's not there, so you assume it's a positive 1. So since it's positive, we know that our parabola is going to be opening upward. So we have a U shape here. Now the vertex, so remember in standard form we had to use a formula to find the vertex, but in vertex form, it's called vertex form because it gives us the vertex. We can go ahead and we pluck it straight out of the equation. So finding the vertex, first thing we do, remember the vertex, okay, I'm going to write this over and over again, is the xy coordinate. Okay, so the x value is going to be the opposite of h because in the formula it's a negative h. So if you look at h, currently it's a negative 4. But we're going to take the opposite of this. So if we have x minus 4 inside the parenthesis, that means that we're going to pull out a positive 4, right? Because we're taking the opposite of h. Comma. So if our x value is 4, now to find the y value, it's just that k value on the outside. Okay, you do not take the opposite of this, you keep it as it is. So for now, our k is a negative 10, which means our y value is negative 10. Okay, so now we can go straight to plugging in our vertex. So it's at 4, negative 10, which is right there. We have our vertex. Step 3, draw the line of symmetry. That's also the same, and it goes straight down through the vertex. That stays the same. Step 4, we find our y-intercept. Same thing for y-intercept. We plug in 0 for x. So plugging in, I'm going to use a different color. We have 0 minus 4 squared minus 10. 0 minus 4 is negative 4. Negative 4 squared minus 10. Negative 4 squared is 16 minus 10. 16 minus 10 gives us 6. So for the y-intercept, we plugged in 0, and we get out a 6. So y-intercept is at 0, 6, and remember to reflect it. It's 1, 2, 3, 4 away from the axis of symmetry. So 4 away on the other side. 1, 2, 3, 4 is our free point. And the last step is to use the strategic points. And I'm going to look and I see that 1 is available, so I'm going to choose to plug in 1. Although you can choose to plug in any number you choose. Any number between here and here would be a fairly good number. You just can't use 0, 4, 8. But I'm going to choose 1. So for strategic point, I'll do it in green. I'm plugging in 1. So let's see what we get. We get 1 minus 4 squared minus 10. So 1 minus 4 is a negative 3. squared minus 10. Negative 3 squared, so that's negative 3 times negative 3 is 9 minus 10. That is negative 1. So 1, negative 1 is my strategic point. So 1, negative 1, that's right there. It's 1, 2, 3 away from the axis of symmetry. 1, 2, 3. And I have my super wide parabola. I'm going to try to draw it. Okay, example 2. Okay, so we're given negative 2 times x plus 3 squared minus 1. So step 1 doesn't open up or down. We look at our a value. It's a negative 2, so we know it opens downward. So we're going to have a sat parabola. So find the vertex. Remember, the vertex is opposite of h. H is currently 3. So the opposite of 3 is a negative 3. Oops. So my vertex is going to be negative 3, comma, k is on the outside here. That's my y value, negative 1. So again, vertex, you just pluck it straight out. Opposite of h, comma, k. Now plugging this in, let's see, negative 3, negative 1. That's my vertex. After my vertex, step 3, draw your line of symmetry. Straight down. Now step 4, Y-intercept. And Y-intercept, you're always plugging in 0. So let's see what we get if we plug in a 0. We have negative 2 times, plug in 0 for x, plus 3 squared minus 1. So simplifying this out, 0 plus 3 is 3 squared minus 1. And you guys can skip steps if you feel confident enough to. So 3 squared is 9. So this is negative 2 times 9 minus 1. That's negative 18 minus 1. That's negative 19. So my y-intercept is at 0, comma, negative 19. So 0, that's right there. And now I'm going to reflect this. So that's 1, 2, 3 away. 1, 2, 3. That's my free point right there. Now I'm going to pick my strategic point. And this time I'm going to choose, let's see. I think I'll choose negative 4. It's right next to the vertex. It makes it easy. So I'm going to choose to plug in negative 4. So for my strategic point, I'm plugging in negative 4, and I'll find out what I get. So it's negative 2 times negative 4 plus 3 squared minus 1. Okay, so inside the parentheses, negative 4 plus 3 is negative 1. So that's negative 2 times negative 1 squared minus 1. Negative 1 squared is 1. 1 times negative 2 is negative 2 minus 1. That gives me negative 3. So negative 4, negative 3 is where my strategic point is. So negative 4, negative 3. And we're going to reflect that to the other side as well. And that gives us the 5 points that we need to draw our parabola. And I tried to make it look nice, but completely failed. All right, example 3. Applying the vertex form. Man. Okay, example 3. So reducing the cost of an item can result in a greater number of sales. The revenue function that predicts the revenue in dollars R of X for each $1 change in price X for a particular item is R of X equals negative 100 times X minus H squared plus 28,900. Right, so I'm going to just go ahead and write this is a times x minus h squared plus k. Okay, and this is going to be hard to graph because that's a huge number right there. Okay, so let's do our 5 steps first. So step 1, does our parabola open up or down? We look at A. A is negative 100, which means our parabola is going to open downward, so we're going to have a sad parabola. Step 2 is finding the vertex. So remember, the vertex is opposite of h. H is negative 7. Opposite of that is a positive 7. So our vertex is 7, comma, and k is this 28,900 number. 28,900. Okay, and then step 3 is always to do the axis of symmetry, the line of symmetry, which we can't do right now because we don't have the graph, but we can do it if we do graph it. Step 4 is the Y-intercept. Remember, for Y-intercept, we're always plugging in 0, and then we'll get something. So if we plug in 0, we have negative 100 times 0 minus 7 squared plus 28,900. See, 0 minus 7 is negative 7. Then negative 7 squared is 49. Right, so I just went ahead and simplified all this. So I did negative 7 squared, which is 49, plus 28,900. 49 times negative 100 gives me negative 4,900 plus 28,900 which gives me 24,000. So my y-intercept is at 0, 24,000. Okay. So before we do strategic point, let's just go ahead and look at the questions to see if we can answer any of these. So what is the maximum value of the question of the function? So remember, it does open downward and our vertex is on top, which means that it's a maximum, right? That's the maximum value that it can be right there. So if we're looking at that, the maximum is going to be this 28,900 number. That's where the highest the vertex goes. That's the y value of the vertex, the vertical, the up and down. So the maximum value of the function, we already know that's going to be 28,900. So we're able to answer one question so far. Let's go to the next one. What does the maximum value mean in the context of this problem? So what does it mean? So it would help if we were to label the x and y values. So if we look, the revenue function that predicts the revenue in dollars, R of x, that means y. So R of x is revenue, and the x is every $1 in change. So $1 change. So now what does the maximum value mean in the context of this problem? So it means, so remember, x means dollar changes, so this is $7 that changed, gives us a maximum revenue of 28,900. So a $7 change in price gives us max revenue of $28,900. Now this next question. What price increase maximizes the revenue, and what does it mean in the context of this problem? That is the same question, so that same answer still applies. So if we increase the price $7, that's going to give us the maximum revenue of $28,900. And then graph the function. And I'll leave that to you guys to graph. I'll let you have all the fun.